Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide.
Beneath Washington's surface lies a secret that could shake the world. A colossal volcanic system stretching through the Cascade Range threatens devastating chain reactions with a single shift. Submerged forests in Puget Sound, remnants of a cataclysmic quake, whisper of ancient destruction. Strange ocean whispers near the Juan de Fuca Plate deepen the enigma, baffling scientists. Let us uncover the truth, a revelation that could redefine our understanding of nature's wrath. Sky Kings and subterranean time capsules. In the remote landscapes of Washington, the curtain has been pulled back on secrets long hidden beneath the earth, within the waters, and amidst the forests. These revelations have ignited curiosity, unearthed hidden dangers, and left experts reevaluating what they thought they knew about the state. Yet as the pieces come together, one shadowy truth looms larger than the rest, a truth that could rewrite the story of Washington forever. First on the list is the discovery of a massive underground volcanic system. Seismic imaging has uncovered a sprawling network of magma chambers that stretch like veins through the Cascade Range. Imagine molten rock silently coursing through these chambers, forming what researchers are calling a magma highway. Unlike the catastrophic eruption of Mount St. Helens in 1980, these chambers reveal a more interconnected and dynamic volcanic system than anyone expected. This is not just an idle curiosity either. Understanding this network might redefine seismic risk assessments for the region. If one chamber shifts, the ripple effects could be disastrous, a chain reaction lying in wait. Researchers have been poring over data to understand how this subterranean network functions and what it could mean for the safety of the area's residents. The presence of these chambers raises questions about how past eruptions shaped the region's unique geography and what potential eruptions could do to modern infrastructure. Then there are the submerged forests in Puget Sound. Divers exploring these watery depths stumbled upon tree stumps preserved in astonishing detail. These ancient forests once stood proudly above ground thousands of years ago, before being swallowed by the sea after a cataclysmic earthquake. Their preservation gives scientists an unfiltered look into an era when the coastline stretched farther than anyone living today could imagine. The trees whisper tales of cooler, wetter climates, backing theories about shifting regional weather patterns. Radiocarbon dating suggests these trees were standing during a time when megafauna like woolly mammoths roamed the landscape. For some, it is a haunting reminder of how powerful nature's hand can be, capable of reshaping entire landscapes in an instant. The details captured in these submerged remains, from growth rings to preserved bark, provide a window into ancient ecosystems that thrived before the seismic event that submerged them. Researchers are continuing to examine these forests for signs of ancient climate shifts that might mirror the changes we face today. And let us not overlook the discovery of a striking new species of salamander in the Olympic Peninsula. This little creature, only a few inches long, dazzles with iridescent hues of green and blue. Its sticky, elongated toes and prehensile tail suggest it is a specialist at navigating moss-covered trees and branches high in the forest canopy. Unlike its aquatic cousins, this salamander thrives on the dampness of moss-laden branches, making it a unique case for researchers. Beyond its beauty, it is a wake-up call about the fragile ecosystems in these ancient forests. With logging and climate change looming as constant threats, this salamander's survival is tightly bound to the health of its environment. The discovery of this amphibian has prompted scientists to conduct further studies into its habitat and breeding patterns, hoping to better understand how such a delicate species has adapted to survive in such a specialized niche. Now, shift focus to the underwater whispers off Washington's coast near the Juan de Fuca Plate. Hydrophones have picked up a series of eerie, low-frequency noises dubbed the Washington Whispers. These sounds are a riddle wrapped in an enigma. Are they the result of gas escaping from deep-sea fissures, or the movements of as-yet undiscovered marine creatures? Adding to the mystery, the whispers' frequency fluctuates unpredictably, with some stretches of silence lasting weeks. These unexplained noises remind us that much of the ocean remains as unknown as the farthest reaches of space. They are a haunting echo of how much we still do not understand about the depths of our own planet. Teams of oceanographers are working to map the source of these sounds using advanced sonar and remote-operated vehicles. The potential for new discoveries, whether geological or biological, keeps scientists returning to these mysterious depths, eager for answers. And then there is the giant bird uncovered in the Cascades, a fossil find that is rewriting what we know about prehistoric life in the region. With a wingspan stretching over 20 feet, this apex predator would have dominated the skies. Its serrated beak hints at a dual role as both scavenger and hunter, preying on smaller mammals and perhaps even young megafauna like mastodons. The debate rages among scientists over its lifestyle. But one thing is clear. This bird's discovery paints a vivid picture of a long-lost world teeming with life and competition. Fossilized remains, including partial skeletons and feather imprints, suggest it was a creature of immense strength and agility. Researchers are using isotope analysis to study its diet and migration patterns, hoping to uncover more about how such a massive bird thrived in the challenging ecosystems of prehistoric Washington. Finally, a buried glacial lake in eastern Washington takes the prize for sheer scale and historical significance. Hidden under layers of sediment, this lake dates back to the last ice age. It is a time capsule holding pollen, microscopic fossils, and minerals that provide invaluable insights into ancient ecosystems and climatic shifts. Once a hub for prehistoric creatures like mammoths and saber-toothed cats, the lake's remains are a treasure trove for scientists aiming to piece together the puzzle of Earth's icy past. Its discovery not only reveals what was, but hints at what could be as climate change continues to reshape the planet. Ground-penetrating radar and core sampling have revealed sediment layers that record thousands of years of environmental history. By analyzing these layers, scientists hope to trace the ebb and flow of glacial advances and retreats, as well as the impact of ancient megafloods that scoured the region's valleys. As Washington's landscape reveals its wonders, questions arise about what else history has yet to uncover. Landmarks of a lost era. The way history is taught often suggests that we have it all figured out, yet cracks in the narrative keep appearing. Conversations like the one between Graham Hancock and Joe Rogan poke at these cracks, especially when it comes to ancient civilizations. One idea that sticks out is the notion of a forgotten global seafaring culture from the Ice Age, one that knew how to map the world long before modern tools came around. When archaeologists discuss ancient seafaring, they often point to the Polynesian expansion, which took place about 3,000 to 3,500 years ago. The Polynesians were incredible navigators, capable of crossing vast distances with astonishing precision. Take Easter Island, for example. This tiny island sits over 2,000 miles from South America and about the same distance from Tahiti. Yet Polynesian explorers not only found it, but established a viable community there. They even managed to make return trips. This achievement is rightly celebrated, but it is also where mainstream archaeology draws a hard line. According to them, large-scale ocean voyaging did not happen before this period. But should we accept that timeline without question? DNA evidence from the Amazon hints at a much earlier connection between distant regions. It challenges the idea that Polynesians were the first to undertake daring oceanic voyages. This evidence deserves more attention instead of being dismissed. Ancient cartography throws a wrench into the established story. Some maps from as recent as the 1300s to the 1700s show the world with details that seem impossible for their time. Take the Piri Reis map, drawn in 1513 by a Turkish admiral. Only part of the map survives, showing sections of South America, North America, and Africa. What is intriguing is that Piri Reis himself wrote that his map was based on over 100 older sources, some of which reportedly came from the Library of Alexandria. This suggests that valuable geographic knowledge existed long before the map's creation. Even more puzzling, these maps include precise latitude and longitude, a feat that should not have been achievable at the time. While latitude could be determined with simple tools, calculating longitude required a chronometer, a device that was not invented until the late 1700s. The fact that such accuracy appears on older maps implies that someone long ago had already figured out how to do it. Maps from centuries ago show Antarctica, a continent officially discovered in 1819, Not only that, but these maps depict Antarctica as it would have looked during the last ice age, before it was covered by ice. Take the Pinkerton map from 1818. It shows no Antarctica because at that time, no one knew it existed. Yet older maps include it, in the right location and with a different coastline. This strongly suggests that someone explored and mapped the continent thousands of years ago. Another example comes from maps that show Greenland's subglacial topography. Modern technology confirms these details, but how did ancient map makers know what lay beneath their ice? These maps challenge conventional timelines and hint at an advanced knowledge that mainstream archaeology struggles to explain. The Bimini Road, located in the Bahamas, adds another layer to the mystery. This underwater structure is often dismissed as a natural formation, but whether it is man-made or not is not the main issue. What is striking is that it appears on ancient maps as an island feature above water. The last time this area was above sea level was thousands of years ago. This suggests that whoever created the original maps saw the Bimini Road when it was dry land. Archaeology tends to sideline such anomalies. Critics argue that these maps are mere coincidences or misinterpretations. But brushing aside evidence like the Bimini Road's placement on ancient maps ignores the possibility that Ice Age civilizations were far more advanced than we assume. Ancient maps may rewrite the past, but Africa's shifting land reveals Earth's ongoing transformation. Africa's geological transformation. Imagine scrolling through your favorite social platform and stumbling across a headline that makes you stop in your tracks. A new ocean is forming in Africa. At first, it sounds wild, like something out of a sci-fi movie. But then you dig deeper, and it's true. A crack over 50 kilometers long ripped open the ground in Ethiopia back in 2005, and it's part of a process that could one day split the continent in two. The story starts in the Afar region of Ethiopia, one of the hottest and most geologically active places on the planet. Back in 2005, the ground literally tore apart when the Dabahu volcano erupted. This wasn't just a regular eruption with a few lava flows. It was like the earth opened its mouth wide. Villages nearby reported seeing flames, ash clouds, and even animals like goats and camels getting caught in the chaos. No people were killed, thankfully, but it left a scar on the land, a massive fissure that has been studied ever since. Geologists call this the East African Rift, a giant crack in the Earth's surface stretching over 6,000 kilometers. It's not new. This rifting process started millions of years ago. Think of the Earth's crust like a cracked windshield. Those fractures and gaps keep spreading. In the Afar region, three tectonic plates, the Nubian, Somali, and Arabian plates, are all pulling away from each other. This triple junction is like a tug of war, with each plate moving in different directions, causing the land to stretch, sink, and sometimes tear apart. Why is this happening? Deep beneath the surface, something called a superplume may be driving the action. Imagine a massive column of hot rock rising from the Earth's mantle, pressing against the crust above. This heat and pressure make the crust thin and weak, like stretching a piece of dough until it rips. Over millions of years, this process has carved out valleys and created volcanoes across East Africa. The Afar region is ground zero for this geological drama. It's where the Red Sea and the Gulf of Aden meet, forming a network of rift valleys. These valleys are the result of the Somali and Nubian plates slowly drifting apart. Geologists predict that in about 5 to 10 million years, water from the Red Sea will flood into the region, creating a new ocean. Imagine standing in Uganda or Rwanda and looking out over a coastline. That's the kind of transformation we're talking about, though it's way beyond our lifetime. Satellite images and advanced tools like radar-based techniques have been critical for studying these changes. Scientists can measure ground movements down to millimeters. In the case of the Dabahu fissure, the Earth's surface shifted by about 8 meters during the initial event. That might not sound like much, but in geological terms, it's a massive leap. This rift isn't just about rocks and cracks. It's also a hotspot for volcanic activity. Mount Kilimanjaro and Mount Kenya, some of Africa's tallest peaks, were born from this rifting process. The Afar region itself is dotted with active volcanoes. Locals have learned to live with this fiery landscape, even harnessing its power. Hot springs and fumaroles, where steam and gas escape from the ground, are used to collect water in this arid region. It's an ingenious survival tactic in a place where rainfall is scarce. Life in the Afar region is as rugged as the landscape. Most of the people here are nomads, moving with their herds of goats and camels in search of water and grazing land. They've adapted to this extreme environment, but it's not without challenges. Droughts, conflicts, and limited resources make life tough. Yet there's a resilience in the way they've learned to coexist with a land that's constantly changing beneath their feet. The East African Rift System extends roughly 6,000 kilometers from the Red Sea in the north to Mozambique in the south. It includes two main branches, the Eastern Rift Valley and the Western Rift Valley. The Eastern Rift runs through Ethiopia, Kenya, and Tanzania, while the Western Rift curves along the borders of Uganda, Rwanda, and the Democratic Republic of Congo. These branches are separated by highlands and plateaus, creating a striking contrast in the landscape. The Western Rift Valley is home to some of Africa's largest and deepest freshwater lakes, including Lake Tanganyika and Lake Malawi. These lakes sit in basins formed by the rifting process, making them among the oldest lakes in the world. In contrast, the Eastern Rift Valley is characterized by its volcanic peaks and arid plains. It's a region of extremes, where the terrain shifts from towering mountains to vast, flat expanses. Volcanoes play a significant role in shaping the landscape of the rift. The Afar Triangle, located at the northern end of the rift system, is a hotspot for volcanic activity. The Erta El volcano, known for its persistent lava lake, is one of the most famous features in this region. This volcano has been active for hundreds of years, with lava bubbling continuously in its crater. The heat from these volcanic systems also creates geothermal energy potential, which could be a valuable resource for the region in the future. One of the most fascinating aspects of the rift system is its role in the history of our planet. The movement of tectonic plates and the formation of rift valleys are processes that have shaped Earth's surface for billions of years. The breakup of supercontinents like Pangaea and Gondwana, which once united all land masses, set the stage for the rifting and drifting we see today. The East African Rift is a modern example of these ancient processes, offering a window into the forces that continue to reshape our planet. The rift is also a treasure trove for archaeologists and paleontologists. The region has yielded some of the most significant discoveries of early human fossils, providing clues about our ancestors' evolution. Sites like Olduvai Gorge in Tanzania and the Hadar area in Ethiopia, where the famous fossil Lucy was found, have become iconic in the study of human origins. These discoveries highlight the unique interplay between geology and biology in this dynamic landscape. While the East African Rift System is a fascinating natural wonder, it's not without risks. The region's tectonic activity can trigger earthquakes and volcanic eruptions, posing challenges for the people who live there. Infrastructure development in these areas must account for the potential for ground movement and seismic activity. Despite these challenges, the rift also offers opportunities for geothermal energy development, which could provide a sustainable source of power for the region. The Afar region, where the rifting process is most visible, is a place of stark contrasts. It's one of the hottest places on Earth, with temperatures often exceeding 50 degrees Celsius. Despite the harsh conditions, the region supports a unique ecosystem. Salt flats formed by the evaporation of ancient lakes stretch across the landscape. These salt deposits have been mined for centuries and remain an important economic resource for local communities. The rifting process also influences the hydrology of the region. The movement of tectonic plates has created underground reservoirs of water, which are often tapped by geothermal springs. These springs provide a critical water source in an otherwise arid environment. The interplay between geology and water resources is a vital aspect of life in the Rift Valley. In the future, as the rifting process continues, the landscape of East Africa will undergo significant changes. The formation of a new ocean will reshape the geography of the continent, creating new coastlines and altering ecosystems. This process will take millions of years, but the signs of change are already visible today. From the towering peaks of Mount Kilimanjaro to the deep waters of Lake Tanganyika, the East African Rift is a testament to the dynamic forces that shape our planet. As the East African Rift evolves, what implications could its transformation have on global geopolitics and resource distribution? Share your thoughts in the comments, like this post, and subscribe for more insights.